Hey PCWorld fans, Adam here with Justin Walker. Justin, thanks for joining me. Tell the fine folks at home what your role is at Nvidia.
So I'm a senior director at Nvidia. I run our product management teams.
Okay, nice. And you're here to talk about this, the actual Founders Edition of the new RTX 5090.
Yes,
We got that in front of us. Not only do we have that, we have one of the PCBs that's featured in it. I've got a whole host of questions because I'll tell you, the audience out there seems to be very impressed with this hardware. I know I am. I think a lot of people were expecting something different, and Jensen came on stage and said, hey, we got a 5090 that's 2 slots, and I was super impressed. So, if we can just go from a high-level point of view, was it important for Nvidia to shrink down the size to a 2-slot design, and why?
Yeah, I mean, it was, of course, important for us to shrink it down. And a lot of it is to be able to fit into more PCBs. Small form factor PCBs small form factor
PCs.
systems.
Yeah.
PCs. Those are some really exciting builds, and I know a lot of our enthusiast community loves doing that, so that's important.
I'm a small form factor fan, so
yeah. I love them as well, and so, getting the size down is, it's great for that, and it's also just an elegant solution. So yeah, getting the size into a reasonable area was certainly important.
Well, I could imagine it was a hard task. Please walk me through some of the steps that it's like, okay, well, we need to, in order to get that small, we need to do this, this, and this.
Yeah, no, absolutely. Our engineering team actually did just a phenomenal job with this. I'm super impressed with what they've been able to do. The fundamental problem with shrinking the design is that you need a lot of airflow. And the best way to get airflow, of course, is just straight and smooth airflow. Mm-hmm. And the problem is you have a PCB in the way. So if you have a PCB, and imagine this thing was nice and long, all of your airflow goes in and it hits the PCB, and then it has to kind of make a right angle turn and exhaust out. And a lot of the times it's exhausted out kind of through a small area. So when the air hits the PCB, you're making the fans work harder to get the air through. And when you exhaust out of a smaller area, the air has to move faster. All that makes more noise. So the challenge with making a smaller design is doing it without making it louder.
Got it, okay.
And so the way to do that is to open up the airflow.
Okay.
And the real challenge with opening up the airflow is what I said back at the beginning, you've got this big PCB in the way.
So you had to shrink, first you had to shrink the PCB?
Yes.
And how'd you do that?
Well, our engineers, that's just one of those.
That's just magic.
That's one of those engineering magic things.
Magicals have sprinkled dust on it. And
that is, that is a lot of hard work and a lot of dedication from a lot of really smart people. And one of the reasons, by the way, that is especially difficult to achieve is that we're not just shrinking this PCB, we're speeding up all of the signals that go through it.
Okay.
Right? We increase the speed of basically everything. We increase the PCIe speed, we increase the memory speed, we increase the display speed. All of them are increased dramatically from the previous generation. So we increase the speeds and shrunk the PCB.
And I've heard you also had to increase the stack to do that?
So yeah, the layer stack, but in addition to that, we actually had to make 3 different PCBs. I'm just showing you one right now. This is the main one.
Yeah.
But the PCB, of course, has to connect to the display right here.
Okay.
And so normally a PCB would extend all the way out to the display. But that's right where we want the air to be flowing.
Okay.
And so the way our engineering team solved that is they created another PCB that sits right here, and that has all the display outputs. It's right in there. It's under.
Yeah, okay.
It's in here.
Probably can't see it.
I'm not sure if you're going to be able to. You can see bits of it if you get in there
maybe
close.
A little bit, yeah.
But it sits right there, and it's connected through a cable that plugs into this, and the cable just kind of runs around the edge there. And what that does is it allows this whole space, let me put it down here so you can get a better view of it, but it allows this whole space to be open for airflow.
Wow, okay.
There's nothing there blocking it.
Anyway, so where does it connect to this PCB then?
It's on a connector here on the back.
Is this it right here?
Yeah, that's the connector on the back there. And then there's actually a third PCB. If you notice one thing about this, there's no PCIe fingers on it. The PCIe fingers are on another
What you're talking about here.
Yeah, this right here. This is a separate board.
Okay.
Right? So there's 3 boards, this main one.
And then where does this sit roughly within this, this
it
height?
sits...
Oh, I guess there's the...
Yeah, put it that way. You can kind of see this sits kind of in the middle here.
Oh, okay.
Like that.
Got it.
And then
you're talking about when you're connecting to the PCIe slot, so then it's underneath.
yeah, so this would sit kind of like that.
Oh, okay. And how big is that PCB roughly?
This one's not very. I mean, it's what you see here plus maybe a little like that. It's a fairly
okay.
compact PCB.
And how is it connected to then this board?
Also here on the back.
Oh, okay.
Here. Yeah. See, there's a couple of connectors on the back.
So this is for the PCIe,
Right.
and this is for the video.
Right.
Oh, okay. Nice. Okay, so then you centralized all the PCBs and all the hardware where it needed, but you needed to get the air through.
Right.
And this is the two fans on
Yes.
a Founders Edition is nothing new, but you had to allow for the maximum amount of flow through, right? What have these fans been updated?
Yeah,
since
absolutely.
the previous version. So yeah, let's talk about the fans first.
You know, we fine-tuned the fans and the fin shape, of course, to get the maximum airflow with the minimum amount of noise.
Okay.
You can see we've maximized the area for the fans. Obviously, a larger fan spinning slowly makes a lot less noise.
It's almost all the way to the edge.
Yeah, you can see how we've just put it right up until the edge. So you maximize the size of each of those fans. You optimize the shape of the fans and the fin stacks in order to move the air straight through with the least possible noise.
Okay.
Another optimization, you can actually, if you flip it over, you can kind of see this.
Yeah, I was going to ask. I
You
felt
note
this concave.
These are a little concave.
Yeah. Why?
So when a fan spins, right, the outer blades are moving faster than the inner blade.
Okay.
And so what that means is you're putting more pressure. It changes the profile of the pressure
Okay.
you're creating, right? The pressure on the outside is different than the pressure on the inside.
Yeah.
Now, to optimize the airflow in the thermals, you would like to even that pressure differential.
Okay.
So the way you do that, when the fan itself is creating a different pressure profile,
Okay.
we even it out by curving the fins.
Okay.
And so those are curved in order to exactly even out the difference in pressure caused by the rotation of the blades of the fan.
Wow. Okay.
This video is sponsored by Silverstone, the leader in PC case manufacturing. The latest Alta D1 is the pinnacle of modular and flexible workstation case design. Featuring multiple modules, high-grade steel construction, and substantial airflow, the Alta D1 is ready to take on the toughest hardware challenges. If the industrial look isn't your cup of tea, then give the beautiful SETA A2 a look, which supports complete backside connector compatibility. Build your next PC inside a Silverstone case.
Tell me about like the significance of how thick the fins are and the density of them.
Yeah, so again, what you're trying to do with the fin is you're trying to maximize the amount of area that the air flows through. Okay. So that's why you have a fin in the first place, right? You have all that area on the side of the fin that the air is flowing over. So you'd like to have as much area as possible, which would say, hey, I want as many fins as I can possibly get in there, so you have more area. Now, you obviously have to you can't put too many in because now you're blocking the airflow.
Yeah, right.
Right, so you have to find that perfect balance of lots of area, lots of fin area, yet still allowing smooth airflow through it. And so that's how that spacing gets determined.
Okay, and speaking of airflow, I've noticed these slits on the sides. I've heard there's a significance for the slits. Please tell me why they're there.
Yeah, absolutely there is. So if you imagine all the air is flowing straight through, right, but it's still inside your chassis.
Yeah.
Now there's an exhaust. Most chassis will have an exhaust, and they'll kind of take it out of the chassis. But some of the air, if you're not careful, can go from the exhaust and circulate back around,
which you don't want,
into the inlet, which you don't want.
Yeah.
You want the cool air here, and you want the hot air out.
Yeah.
So the way we've addressed that is to angle some airflow out of these slots to make sure the air stays going in the correct direction and doesn't recirculate back into the fans.
So it's like creating a boundary.
Yeah, it's sort of imagine you've got this like little air boundary here pushing the air back over where we want it.
Okay, nice, interesting. And so from what I've heard, the 5070 actually has a slightly different design.
Yeah, the 5070 design is similar to our previous generations.
Oh, okay.
You know, this design is needed in order to get that like flagship, really high performance into a small form factor.
Nice. Okay.
And so we had to clear up a whole lot of area and you know obviously to create a lot of airflow in order to make that happen.
Yeah. Well, speaking of condensing area space, obviously you've got a single 12 volt 2x6. Can you confirm if it's 12 volt 2x6?
Yeah, that's it.
Okay. And so it's also coming in at an angle, kind of like the 30 series, right? Is that the first time?
Yeah, we had one like that on the 33.
Okay,
series.
yeah. And I guess, I don't know if you can answer this, but how much power can this actually take?
Well, the connectors can handle 600 watts of power.
Oh, okay.
That's the spec on these connectors. So that's of course what you can put in there.
Nice. Has there been any design changes to the 12 volt 2x6 compared to like the 4090?
No, I mean, other than the fact that it's angled, it's just an industry standard connector.
Okay.
Now, the reason it's angled, by the way, is because when it comes, a lot of these times you're going to put it in a PC, and the side of the PC is kind of right there.
Yeah.
Right, and so when it's straight out, that connector can bump into the side of the PC, and it just goes straight up. And so this way you can just lay it nice and flat on the side, and we actually have a power adapter that is nice and flexible, so you can just take it and just move it off to the side there. So
nice.
if you're a cabling freak like me, and you want it to look nice and clean, you can just take it and kind of angle it down and out of the way, just like that, and it's just got a very nice, clean design inside the PC.
Would that block any airflow by having the cable come in front of the fan?
No, the cable's small enough that it doesn't really get in the way.
Okay.
So.
I mean, the other way obviously is to wrap it here, but then you
then you don't get to see your LEDs.
Yeah. So you've got LEDs here, and then
Yep.
there's a couple LEDs on the V shape here.
Yep.
Are those
correct.
addressable, or is it just white?
That's just nice white.
Oh, okay. Nice. No GeForce green or anything. Like that?
No, we're keeping it clean.
Okay. Well, congratulations to the engineering team for this fine card.
Yeah, they've outdone themselves.
Yeah, no, and I appreciate you talking to me about this, and hopefully you found out more about this beautiful 5090 design. So if you have any questions, put them down in the comments below. Thank you so much for hanging out with us, and we'll catch everyone later.
Thank you. Bye-bye.